Assalamu alaikum. My name is Mohammad Daniel Ali. My role number 20T16. I am here back again for the lab task 2, lab 2 for of DSP. As you can see, we have performing a task 1. So where you can see that we are performing a step signal function. We define that, and we have given three numbers. And 0 is equal to -1, and 1 is equal to -3, and 2 is equal to 3, which we have defined that, and we have to find the n of n1 of ratio and 2, generating the index and the following generate with the step signal desired. So we will get our desired signal. As we're gonna run through, you will see what is the desired signal, steps desired signal. So here is the signal. As you can see that it is giving a different answer of showing that discrete values. The graph, here you can see straight lines. We define everything. Now moving on to the task 2. Task 2 is about the step signal value chain, how value changes in the step signal. As we can see that we have changed the values of n0 1, and 1 is equal to -5, and 2 is equal to 5. And as for that, we have applied the function, and we are going to run now. As we have run here, we can see on another video that we only get a one discrete value, as by giving the values, showing that it only shows us only one discrete value, which tells us that with the function n0 is 1, which only shows on the graph. So we will cross it here, and move on to the next one, task number 3, which is about the exponential decaying signal, which defines defines the exponents, how signal is decayed. So here you can see values as we have changed the values and applied the stamp function, and stamp function n of x and comma x. So we are gonna run here. After running the program, opening another window, you will see the graph differently. With that, the graph, after joining the points, it form a curve, which shows that the graph is rapidly decreasing from y-axis to x-axis as for given points. So we will cross it here, and move on to the next task 3a, which will show that we have to find the sinusoid sequence, which will define the sinusoid sequence as by putting the values of the n1 and n2 differently, -10 or 11. We, after putting the post formula, which will give us a different answer on the graph, we will run. After running, so as we have run, it will show in the other window. As you can see, it is a reflection of the first graph of the second one, but with a different value because of the cos formula. As we have applying after one, it in a 270 to 0 to 270 to 360 degree, sorry, 180 to 360 degree angle, which shows the reflection of the graph in discrete values. So which will cross it here, and move on to the next task, task number, sorry, lab task number 4. We moving on to the task number 4. As you can see, we have to define the unit impulse for direct function, which will show us what is the impulse direct function unitally. As you can see, as we have put the n values, ratio n -10 ratio 10, after implying the function x of 0 1 of 1 comma 10 of 1 0 is 1 comma 10 of bracket. After running, it will show that it define only one discrete angle from in through x-axis, moving through y to x-axis, as it is shown. As you can see, for now, moving on to the unit impulse function. What is unit impulse function? You will define the different values unitly by implying on it. As you can see, n is equal to n1, as we have given the function. So moving to task 4a, which we have given the values in the unit function as we performed earlier, that applying the code. After running, it will show you the real values we have implied. As you can see, it has started from 1 to 11, but it implies that only at 6 point six number, the values is increased. So moving on to the unit step function unit step, we defined the backend code of the unit step function. By applying this function, we can find the value of we can find the value of the we can find the value at discrete numbers. As you can see, we have applied the axis -11 11 -1 2. By running it, it will show that the axis we have put is it shows the discrete values of a given graph by implying from minus 10 to 10, as you can see there. From y-axis to x-axis, it shows that after 0 in x-axis, it is discrete. Now moving on to the lab 6, which is where in which we have to find the values from function by implying the function. X of n is equal to 3 of you, we have defined three variables, x1, x2, x3. First of the unit step function, second of the unit impulse function, third is the unit step function. By finding these three functions after running, it will show the discrete values. Show that in the command window 00111104, as our answer is given here, because of the three step function which we have defined in the earlier tasks. So moving on to the task 7, which will define the film random signal. It will define the random signal by applying the title of the original signal and by applying the title of the flipped signal. Yani it define both signals, the original one and the flipped one. Flipped one will be opposite of the original one. As we after running, it will show that you can see of the original signal, it is shown in x-axis, and as for the flipped signal, opposite of the signal, it is shown as the y signal. Now we'll cross it and move on to the lab task number 8. It is defining the scaling of the signal, how signal is scaled on a graph. As you can see, as signal is defined here by using the scale factor function, where x is equal to 2. We have applied the hold on function by plotting the signal. By plotting the signal, we have the original signal and the scale signal. After running, it will show how it will work. The original signal is moving to the point 1 to point 7, as for the scale signal, it's moving from the point 1 to point 7 and so on, where it is uncatchable, as you can see by implying it, because it has no hold on function as for the original function. Now showing the other task of it, we can now I'm going to show you other task number 9, which will define the shifting of how signal is shifted. On the other hand, as you can see, we have given the line space 0, 10, 1,000, as we have given y variable. After running it, it will show you the different signal. As you can see, the original signal is same of the standard signal, but for the shifted signal, it has slightest change in it. As both are standard signal, but both have slightest change after implying the different functions. Now for the task 10, as you can see that we have applied that we are going to represent continuous and discrete in zero order hold. How it works, as we have given the values by running it, it will show you that what is the main difference between them. As for the continuous signal, continuous going continuously, sinusoidal waveform, and as for the discrete time signal, it is moving one at a time, forming a curve from 0 to 1 of the different for different x-axis to y-axis. now Now for the task 11, which is a first order hold, how it's gonna work, as we have given the all values, it will have the input to signal, and on the other hand it will have output signal. It will have both type of signal. By plotting it, it will show us the both signal, the input signal and the output signal. So I will show you how the signal is gonna plot as I'm gonna run here. So you can see that as for the input signal, it has a different plot, different subplot, and as for the output signal, a different subplot. Yeah, as you can see that the input signal is in a discrete form, and as for the output signal, it is increasing from the in the graph from 0. After 0.005 to 0.4 by applying the different function. So this is from my side. This is the lab of DSP2. Thank you.